So these are going to be the notes for tangents, section 12.1. The objectives are I'll be able to use properties of tangents, and I'll be able to solve problems including circumscribed polygons. So first we need to know what a tangent is. If a line is a tangent to a circle, that means that we have a circle and a line that goes through it at exactly one point. That's what a definition of a tangent is. If you want to look at section 10.6 and 10.7 of your notes, tangents are talked a little bit about there. It says if a line is tangent to a circle, then it is perpendicular to the radius. So that means a 90-degree angle is formed. And we call that point the point of tangency. So there's only going to be one radius that's going to touch that point of tangency, and it's going to form a right angle. So since we're talking about right angles, we can form right triangles. That was one of our previous units. It was 2 units ago. And it says RS is tangent to circle Q. Remember, we name a circle by its center, which is Q, at point R, and we're asked to find Y. Well, right here, this is a right triangle. So we have a squared plus b squared equals c squared. So c is 20, that's the hypotenuse, and we have what we're going to call x and 16 squared. So x is going to be equal to the square root of 20 squared minus 16 squared, which comes out to be 12. So that means this part is equal to 12. Well, we're asked to solve for y. The radius of this circle is 12. Y is the diameter. So that's just going to be 24. It's going to be double the radius. So for number 2, we're asked to find A. A is this part here. We know that the radius has to be 20 because 40 is the diameter. So we have A squared plus 20 squared is equal to 25 squared. So A is going to be equal to the square root of 25 squared minus 20 squared, which is going to be 15. So that's how we do these problems. That's a little bit of a review of the Pythagorean theorem, which hopefully you're familiar with. So number 3 says you are standing 14 feet from a water tower. The distance from you to the point of tangency on the tower is 28 feet. What is the radius of the water tower? So again, we have a right triangle here. This one's going to be a little bit more complicated. It should be easy to see that our legs are going to be r squared plus 28 squared. But our hypotenuse is going to be r plus 14. We're going to need to take that quantity squared. We're going to need to recall a little bit of algebra to finish solving this problem. First off, though, I'm going to take what 28 squared is. That's 784. So I have r squared plus 784. And I'm going to write this to the side. This is going to be something that's going to be very important whenever you go into Algebra 2. Whenever we expand this, we get this right here. So what I'm going to get is r squared plus 2 times 14 is 28r plus 14 squared, which is 196. What happens with the r squares is that they're going to go away because there's an r squared on each side. I need to subtract 196 from each side to solve for r. So I have 784 minus 196. So I get 588 is equal to 28r. The last thing I do is divide by 28. So we take 588 and divide it by 28. So we get R is equal to 21. So I would expect you to have some difficulties with this, but if you're struggling to see it, maybe watch the video again, and we're going to do a couple examples like this in class. So another theorem is if a line is perpendicular to a radius of a circle, and its endpoint is on the circle, then the line is a tangent to the circle. So this is kind of backwards from our first theorem that we started the lesson off with. So here's a couple examples we have. We have WE as tangent to angle D, or it's asking us, is WE tangent to circle D? Well, we need to find out if this is a right triangle. So does 10 squared plus 24 squared equal 10 plus 16 squared? That's 26. So let's use our calculators to verify it, if this is true or not. So 10 squared plus 24 squared is 676. We can even enter it like this so long as we have the parentheses. So yes, it will be, because 676 equals 676. So that's sufficient to show it is tangent, it's a right triangle. So if we take a look at number 5, does 7 squared plus 9 squared equals 7 plus 7 squared? So 7 squared plus 9 squared is 130. 7 plus 7 squared is equal to 196. So 130 does not equal 196. The Pythagorean theorem is not true. So no, it's not a right triangle. Let's move on to the back page. It says if two segments form the same length, so I think I put in the last part here. Sorry about the delay there. I had to look it up to make sure. So it says if two segments share the same endpoint. So there's a bit of a typo here. If two segments share the same endpoint, here that endpoint is point E, then the segments, if two segments share the same endpoint and are tangent to the circle, then they are congruent. So I think that's what we want to say. So those two segments DE will be congruent to DF. So solve for x and y, assume that the segments which appear to be tangent are tangent. So our last little theorem here says that 4x is going to be equal to 2x plus 8. So we just solve for x. We're going to subtract 2x. 2x is equal to 8, and we're going to divide by 2. X will be 4. We're going to do something exactly the same for 7, which I want you to do on your own. We're going to do 8 together, though. We get x squared minus 1 is equal to 24. So x squared, we're going to add 1 to each side, is going to be equal to 25. When we take the square root, we're going to get x is equal to plus or minus 5. This is a big deal. X is going to have two solutions, plus or minus 5. Most of you probably haven't seen that since algebra, so I wanted to make sure that you got exposed to that. We also need to know about circumscribed polygons. It says a polygon is circumscribed around a circle if each segment of the polygon is tangent. So we have 4 segments that are all tangent to the circle. They only touch in one place. So we're asked to find the perimeter of some of these things. So this says triangle HJK is circumscribed about circle G. Find the perimeter of triangle HJK if NK is 39. So using this information, NK is 39. We know that these 2 segments are congruent. That's one of the theorems we learned before. We also know that these 2 segments are congruent and these 2 segments. So the perimeter is just the length of the outside all added up together. So what we're going to have is 16 plus 39 plus 39 plus 18 plus 18 plus 16. And we get 146. So the last one we have is, it says triangle NOT is circumscribed about circle M. Find the perimeter of triangle NOT if NT, so here's NT right here, is 71. So if this is 71, CT has to be 71 minus 52, which is 19. So again, we know that's going to be 19, this is going to be 10, and this is going to be 52. All those sides are going to be congruent because they're all tangent. That's what it means to be circumscribed. So there's a faster way you can do this in your calculator. This is how I would do it. Let me see if you're able to follow along with this. 162. So what I did was add 52 twice, 10 twice, and 19 twice. This is maybe a little bit of a shortcut, but not that much from just entering in the 6th edition problems. So the answer is 162 for number 10. And that's it for your notes. Hopefully tangents made sense. I think that we might have some problems with the algebra, which we're going to talk about next class. Have a great day.